Hello friends, welcome to a new video of I Square. We were dealing with the chapter sets and we have learned so many important concepts from the chapter sets. So in today's class we are learning more new concepts and the first among them is Venn diagram. What is a Venn diagram? A Venn diagram, as the name suggests, is a diagram, which means it is a pictorial representation. Pictorial representation of what? It is a pictorial representation of relationship between sets. In the previous class we have learned what is a universal set. A universal set is a set which contains all other sets in a particular scenario. Now let's consider universal set as the set of natural numbers, and in Venn diagrams the universal sets are usually denoted by rectangles. So universal set is usually denoted using rectangles and all the subsets of the universal sets are denoted using circles. Now we know what are the subsets of natural numbers. We know that the set of even numbers, that is 2, 4, 6, 8, etc. are the set of even numbers, and it is a subset of our universal set, that is natural numbers. Now what are the remaining numbers in the set of natural numbers? They are odd numbers, which means that does not belongs to this particular circle because this is a subset which denotes the set of even numbers. So the set of even numbers lies outside the circle, and that particular region we have odd numbers, that is 1, 3, 5, 7, 9, 11, 13 and so on. So this particular circle denotes the subset even numbers and the rest of the portion denotes the set of odd numbers. So Venn diagram is a pictorial representation of relationship between sets. So let us keep Venn diagram aside and we will discuss about it more later. Now we are going to study some operations on sets. We have already learned what are the operations in the set of numbers, that is addition, subtraction, multiplication, division. These are the basic operations regarding numbers. While doing operations in numbers, for example, we can operate between 2 and 4. Let's add them. That is 2 plus 4. That is adding the numbers 2 and 4. We get another number, that is 6. So while doing operations between any two numbers, we will get another number as the result. So likewise, while performing operations on sets, we will operate between two sets and the resulting answer will be also a set. So rather than addition, subtraction and all other things, we are going to learn some new operations on sets. Let's know what are they. The first and basic operation on sets is union of sets. Union of sets. For example, let A be the set 2, 4, 6, 8 and B be the set 6, 8, 10, 12. Now we have two sets here and we are going to take the union of these sets, that is a new operation. Union is a new operation for sets. So we are going to take A union B, that is union of the sets A and B. Then we know that we denote addition using this symbol, subtraction using this symbol, multiplication by this symbol and division by this symbols. For numbers we use those symbols, and here for sets that symbol denoting for taking union of sets is this particular symbol, that is this one. Now we are going to take the set A union, the symbol of union is this B. So we are going to take A union B. What is A union B? Or how will we find A union B? It is, A union B is the collection of all the elements from A and B. That is, we have to list out all the elements from A and B. Now, what are the elements from A and B? Here we have 2, 4, 6, 8. So we have completely listed out all the elements from A. Now we have to list out all the elements from B also. What are the elements in B? 6, 8, 10, 12. 6 and 8 are already written here. So we don't want to repeat it again. Now the remaining terms we have to write are 10 and 12. So this is the union of A and B. So A union B is the set of all elements from A and B. Look here, all the elements of A are present here, that is 2, 4, 6, 8. And all the elements of B are also present here, that is 6, 8, 10, 12. So A union B is the set of all elements from A and B. Now let's consider another example. Let X is equal to A, E, I, O, U and Y is equal to A, I, O. We have X and Y, two sets, and we have to prove X union Y is equal to X. Prove that X union Y equal to X. We have X here, Y here, and we know how to take union of two sets, and X union Y is simply the collection of all elements from X and Y. X have A, E, I, O and U, and Y have A, I and O. A, I and O are already present in X and we have already written it here. So this is our set X union Y. So X union Y contains all the elements of X, that is A, E, I, O and U, and it contains all the elements of Y, A, I and O. A, I and O are also present here. So this is X union Y, and we can clearly say that A, E, I, O, U is the set X, so which is equal to X, and hence the proof. So I hope it is clear that what is the union of two sets. It is simply the collection of all the elements from both the sets. So in A union B there will be every element of A and every element of B, but no other element from outside these sets. So that's A union B. Now we shall move to some basic properties of union of two sets. Before going to the properties of union of sets, we have to know the set builder form of union of two sets. That is, A union B can be represented as the set of all X such that X belongs to A or X belongs to B, which means A union B contains all the elements from A and all the elements from B. If X belongs to A, that will be in the set A union B, and if X belongs to B, then that should be also there in A union B. So that is it, the set of all X such that X belongs to A or X belongs to B. Now what are the properties? There are 5 properties regarding the union of two sets. First property is commutative property. That is, A union B is always equal to B union A. Now let A is equal to 1, 2, B is equal to 2, 3. Then we know that A union B is all the elements from A and B, that is 1, 2 and 3. And we know that B union A is all the elements from B and A, and they are 2, 3 and 1. So it is clear that A union B equals to B union A, because every element of A union B is there in B union A, and every element of B union A is in A union B. So A union B is equal to B union A. That is the first property. That is commutative property. Now the next property is associative property. That is A union B union C is equal to A union B union C. So let C is equal to set 3, 4. Then A union B union C. That is A union B union C is elements from B and C, that is 2, 3 and 4. Now A union 2, 3, 4. A is 1, 2 and what is A union 2, 3, 4? 1, 2, 3, 4. This is A union B union C. Now we have to find A union B union C. So first we have to take A union B. A union B is nothing but 1, 2, 3 union C. What is 1, 2, 3 union C? That is again 1, 2, 3, 4. That is A union B union C is equal to A union B union C. That is associative property is also true for the union of sets. Now this is the next property. A union phi is equal to A. We know that phi is the empty set and a union of a set with phi is always that set itself, because an empty set contains no elements. Therefore, in union also the answer will be that set itself, that is A. What is universal set union A? Universal set is the set which contains all the elements. Therefore, it contains all the elements from A also. So, the union of universal set and A will be always the universal set. Now, A union A. In this example, A union A is nothing but 1, 2. That is all the elements from A and all the elements from A, that is A itself. This is also called idempotent law. That is A union A is equal to A. That is union of the same sets will be always equal to that set itself. So these are the 5 properties regarding union of sets. Now the next operation is intersection of sets. When will we say that two sets intersects, or what is the intersection of two sets A and B? A intersection B, or the intersection of two sets A and B contains the elements which are common to both A and B. Other than union contains all the elements from A and B, but in intersection of two sets, it contains only the elements which are common to both A and B. And intersection, it is denoted using the symbol, this one. This is the symbol used to denote intersection. Now, two sets A and B intersects, and the intersection contains the set of all elements, that is the set of all x sets, that x should belong to A, x should belong to A and x should belong to B also. That is, the x should be a member of both A and B. Then only we can put x into our new set, that is A intersection B. So, the intersection of two sets A and B contains all the elements which are common to both A and B. Now, let's consider an example. Let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. And in the some time before, when we studied union, we have taken the union of A and B. Now we are going to take the intersection of A and B, that is A intersection B. Intersection is denoted using this particular symbol. What is A intersection B? It is the set of all elements such that those elements should belong to A and B. What are the elements common to A and B? 2 and 4 are not common to A and B because 2 and 4 are here, but it is not present in B. But 6 and 8 is present here and here. So 6 and 8 will belong to A intersection B. What about 10 and 12? 10 and 12 belongs to B only. It does not belongs to A, which means they are not common to both A and B. So the only elements common to both A and B is 6 and 12. So A intersection B is 6 and 8. So A intersection B is nothing but 6, 8, the elements which were common to A and B. Now, like the previous question we have done in A union B, let A, E, I, O, U be the set X and Y be A, I, O. And here we are going to prove that X intersection Y is equal to Y. How will we prove that? We have to take X intersection Y first. What is X intersection Y? It contains the elements which are common to both X and Y. Here we have, while writing the intersection of two sets, always start with the smaller set. So this is Y is the smaller set, and we are going to check whether every element of Y is there in A, and if and we will write in X intersection Y the elements which are present in X. Now A, I, O. We are going to check whether A, I and O is here. A is here, I is here, O is here. So A, I, O is present in X, which means A, I and O are common to X and Y, which means intersection of X and Y contains A, I and O, which is our set Y. So we have proved that X intersection Y is nothing but Y. That's it. This is the intersection, the concept of intersection of two sets. We started with two sets A and B, and when we intersect them, that is A intersection B is the set of all points or set of all elements which are common to both A and B. Now we shall see some basic properties of intersection of two sets. Now these are some basic properties of intersection of two sets. First property is A intersection B is equal to B intersection A. It is the commutative property for intersection of two sets. Let A be the set 1, 2 and B be the set 2, 3. Then what will be A intersection B? The elements which are common to both A and B, and here it is 2 only. So A intersection B is 2. Now what is B intersection A? The elements which are common to B and A, and we know that for B and A the common element is 2 only, so it is 2, and both of these are equal, and hence A intersection B is equal to B intersection A. For any example you take, you will get A intersection B is equal to B intersection A. Moving on, find out whether A intersection B intersection C is equal to A intersection B intersection C. Now let's consider C as 1, 3, 5. Now what is A intersection B intersection C? What is A intersection B? A intersection B is 2. What is A intersection, that is 2 intersection C? If we look, we can find that there is no 2 in the set C, and hence the intersection contains no elements, so it is the empty set. What about A intersection B intersection C? First we have to take A intersection. What is B intersection C? B intersection C, and B and C contains a common element, that is 3. So A intersection B intersection C is nothing but 3. Now we have to find A intersection 3. A does not contain 3. Therefore A intersection 3 is also empty set, that is 5. So A intersection B intersection C is 5. Also A intersection B intersection C is also 5, which means both are equal. We can prove all these properties using Venn diagram, that we will discuss in another class. Now what is A intersection 5? And 5 means empty set and A is any set. A intersection 5. So which are the elements common to both 5 and A? Since 5 contains no elements, there is no element to intersect with A, so we can say that their intersection should be also an empty set, that is 5. Now what is A intersection universal set? Universal set contains too many elements and A is a small subset of the universal set. So intersection of U and A is again A only, no other elements will be there. So A intersection U is A. For example, this is the universal set when we draw the Venn diagram, and this is our A. And what is the common elements which are common to both A and U? It is the set A only. So we can say that A intersection U is equal to A. Now what is A intersection A? A intersection A only. So here also we have A. So both the elements, which are the elements common to A and A? It's A itself. So A intersection A is again A. Now this is the distributive property, that is A intersection B union C is equal to A intersection B union A intersection C. We can solve this also using by Venn diagram. It is easy to prove all the properties using Venn diagrams, both the properties of union and that of intersection. Now I am going to prove this particular property, sixth property, distributive property, using Venn diagram, and you can yourself do all the other properties using Venn diagram, and also the property solved for union also using Venn diagram. Consider this, we want A intersection B union C first. We have the universal set, this is the universal set, and we have three sets A, B and C. A, B and C. What is B union C? B union C means the set of all elements which are there in A or B, that is the collection of all elements from we are talking about B union C. B union C contains all the elements from B and C. So the complete B should be included in B union C. Also the complete C should be included in B union C. So this shaded region is our B union C. We want to intersect that with A. So this circle is A and this shaded region is B union C. The intersection of A and B union C is the points which are common to A and B union C. The points which are common to A and B union C are this portion, this particular portion. So let it be there. Now we want to draw A intersection B union A intersection C. For that, let's draw another Venn diagram. We have the universal set here. Again we have A, B and C. Now we want A intersection B first. This is A, B and C. What is A intersection B? The points which are common to A and B. These are the points which are common, or elements which are common to A and B. Now we want A intersection C. Now we have drawn A intersection B. Now we want A intersection C. What is the points? What are the points which are common for A and C? There are no points which are common to A and C in this particular diagram. So it is simply empty set. So we don't have to shade them. So what is A intersection B union A union C? We know that any set union, in the previous, when we learned about union of sets, we have learned that any set union phi is simply that set itself, that is A itself. So here we have A intersection B, this is phi, and A intersection B union phi is simply A intersection B, which means it is this portion. And see this, here also we have this portion, here also we have this portion. So it is clear that A intersection B union C is equal to A intersection B union A intersection C, whatever be the sets A, B and C. So these all are the properties of intersection of sets. So in total, every property of union of sets and intersection of sets can be proved using Venn diagram. Venn diagram is an easy tool for solving all the practical problems related to sets. So keep in mind and keep thorough the properties of intersection and union and also the definition of intersection and union, and try to solve using Venn diagrams. Now we are going to learn what is the difference of two sets. What is the difference of two sets A and B? It can be represented or denoted like this: A minus B. Then what will be A minus B? What is the difference of the sets A and B? So A minus B is the set of all elements from A which does not belongs to B. That is the set of all x such that x belongs to A, and there is one more condition that x should not belongs to B. That is the set of elements from A that does not belongs to B. So from A we have to take away all the elements that are present in B, and the remaining set is called A minus B. Then what will be B minus A? B minus A can be the elements set of all x such that x belongs to B. X should belongs to B, but x should not belongs to A. That is B minus A. So B minus A is the set of elements from B which does not belongs to A. That is set of all x such that x belongs to B and x should not belongs to A. Let's consider an example. Let's consider A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Now what is A minus B? A minus B contains the elements or the set of all x such that it should belongs to A. That is 2, 4, 6, 8. There is one more condition: it should not belongs to B. Therefore, to find A minus B, we have to take away the elements from B from A. The elements of B are 6, 8, 10, 12. If 6, 8, 10 or 12 are found in A, we have to remove that while writing A minus B. 2 and 4 are in A, but they are not in B. Therefore, we can write 2 and 4 here. 6 and 8 are in A, but they are in B also. According to our definition, x belongs to A and x should not belongs to B. Since x 6 and 8 belongs to B, we cannot include them in our A minus B. So this is our A minus B. What about B minus A? While writing B minus A, we should start from B. Look into B. In B we have 6, 8, 10 and 12. And we have to eliminate or take away the elements from A, which if some elements of B are from A also, then we have to take away that. So A contains 2, 4, 6, 8 and this 6, 8 is present in B. So we have to remove that and write the remaining numbers, that is 10 and 12. So A minus B is 2, 4 and B minus A is 10, 12. So it is clear that the difference of two sets is not commutative. That is A minus B is not equal to B minus A. Now let's consider another example. Let's take A as A, E, I, O, U and B as A, I, O. Let A is equal to A, E, I, O, U and B as A, I, O. Now what is A minus B? We have to remove all the elements of B from A. We have to remove A, we have to remove I, we have to remove O. So the remaining elements are E and, we have to remove O. So the remaining elements are E and U. So this is our A minus B. Then what will be our B minus A? We have to remove from B the elements which are present in A. What are the elements present in A? A is present in A, so it should be removed. I is present in A, so it also should be removed. O is present in A, so it should also be removed. So B minus A is simply an empty set. It contains no elements because A, I and O are also present in A. So B minus A is an empty set. Now let's represent this A minus B and B minus A using Venn diagrams. How will we represent that? We are going to represent it in Venn diagram. Now this is our universal set. Let this be A and this be B. So we have two sets A and B. We want to write A minus B first. A minus B, that is the set of all elements from A, but it should not belong to B. If we note that this portion contains the elements which are only from A, but if we shade this particular portion, it is the elements which are common to A and B. What are the elements common to A and B? It is called A intersection B. So A intersection B should be subtracted from A in order to get A minus B. So this is the region, that is A minus B. This is A minus B, this shaded region. Now what is B minus A? To find B minus A, we have to consider the B. And we have to remove the elements of A from that. We know that this is a region which is common to A and B. So we have to remove this region. So our B minus A is the set of all elements which belongs to B but which does not belongs to A. So this is our region B minus A. So look at here. This is A minus B. This is B minus A. And this is A intersection B. So it is an important point to note that A intersection B, B minus A and A minus B are disjoint sets. Disjoint sets. Now in this case, what are disjoint sets? Disjoint sets are sets whose intersection is an empty set. If we say A and B are disjoint, if we say A and B are disjoint only if A intersection B is equal to 5. Their intersection should be an empty set. Here we can clearly say that A intersection B, B minus A and A minus B are disjoint sets because there are no points common to A intersection B, B minus A and A minus B. The intersection of A intersection B and B minus A. This is A intersection B, this is B minus A. There is no element common to both of them, so they are disjoint. So their intersection is empty set. What about B minus A and A minus B? This is B minus A, this is A minus B. There is no element common to both of them. Therefore their intersection is an empty set. Therefore they are disjoint sets. What about A intersection B and A minus B? This is A intersection B, this is A minus B. There is no element common to both of them. So therefore their intersection is an empty set. Therefore they are also disjoint set. So keep in mind what is a disjoint set, and also keep in mind that A intersection B, B minus A and A minus B are disjoint sets, and we represented it using the Venn diagrams. So that's all for today's class. We have learned what is a Venn diagram, what are the different operations on sets. We have learned union of sets, intersection of sets, difference of sets, and we have studied various properties of union and intersection. Keep in mind all the properties and all the definitions very thoroughly, and in the next class we will solve the exercise related to these content. So study well and wait for the next video. Thank you for watching. Bye bye.